Hello and welcome to Live Coding with Gerph. Today we are looking at a new series. We are doing some work on kernel introspection. I will talk about what that is. I've planned out a load of different things that we need to do to make RISC OS 64. Not all of which are complete, not all of which are well specified or anything, but as part of phase 2, we haven't finished phase 1, but we're going to jump a little bit into phase 2 just to have a look at this one, where we do some additional work. So one of the first of these things is kernel introspection, and we're only meant to get this as far as being a stub, so we're not going to be doing a huge amount of work on this. It's basically just setting it up. So this is the page that describes things. I will paste that into the chat. There we go. So this is the page that describes what we're doing, and essentially this is going to be a set of routines that will just provide information about the kernel itself, well, about RISC OS itself specifically. It's actually in the kernel introspection about the rest of the system. Here we are. We have a number of different routines, some in OSByte, some in OSRead sysinfo, some OS memory routines that I've decided we're going to pull out, some OS platform calls, and memmapinfo. So all of these are going to be essentially just stubbed. We're not going to be able to do anything useful because, for example, with the memmapinfo, we don't have any memory management system. So all we're going to do is just providing the interface, and then we can fill in the back part of that, the back end half of it, at a later date. So that's the goal right now. So how do we do this? Anything else it says importantly in here? No, nothing particularly special. No, that's about it. All right. So the idea is we're going to go and implement these things, and we're going to go and make them available, and then we'll test them and make sure that they work. So basically we're getting the RISC OS side rather than the back end part working. So first thing to do is to create a Git repository that's got things in. So actually create a directory is the first thing, isn't it? RISC OS kernel introspection. Kernel introspection. Oh, sorry, I also said, should have said, this was suggested by Chris Williams, who is also here today. Hi, Chris. That was at the end of the last series. I asked people to have a quick look through things and decide what they'd like to see, and Chris suggested it looked intriguing, so that's what we're going to do. It might not be that intriguing, but we'll have a see. So let's get some bits working. Set up a Git repository, and then we'll get a project working. Create, I don't want to evaluate expression. Let's see what we'll have. Kernel introspection. And I think we're going to start out by making this a module, because there's no point in doing it as a command line thing, because it is just the stubs we're going to be doing. When we get to the implementation, the actual low end part of it, we can potentially make that into a command, but we'll start with a module. So we'll create a module and a skeleton to go with it. And now we can see, here we go, we've got some bits. So let's create a new window for this directory. And it's popped onto the other screen. Here we go. We are. All right. No, come on, move it down. Thank you very much. Right. So we've got some module. There's some bits there. So let's build that. It's built. If I just go and refresh the side pane, I can see that the H files appear. There we go. It's a H file as well. Okie dokie. So there we got a basic module. So let's create the other bits as well. Sorry, RISC OS project, create Git files and some CI files as well. So status Nothing on there. Good. Add .git attributes, git ci, git build. Oh, I don't want the GitLab one. I want the GitHub one because we're building it on GitHub. GitHub one, git ignore, makefile, c, cmhg, h, version num. Is that everything? I think that's everything. Yeah, just left the CI file because we don't give the GitLab one because we don't need that. Although I could add it anyway. I mean, it's not really important. Commit skeleton kernel introspection module. Just a skeleton from the RISC project tool. Bum, bum, bum. And we can't just push it because we need to create a repository first. So let's create a repository, shall we? GitHub. They've changed the style. I much prefer it. Oh, feed now appears here. It didn't used to. It used to only show us this. They've clearly just changed that recently. Yeah, I can get to see all what my people I'm following and things are doing there. Not that we care, because what I want to do is create a new repository, which is a plus new repository. RISC OS kernel introspection. Description: RISC OS code to implement introspection on the OS. Visibility is public, no readme. Oh, that's changed the icon as well. I'm sure it used to look different. Add a git ignore, no. Add a license, no. All good. Oh, and if I'm I hadn't thought of doing this for the other ones. What we could do. Oh, I can't do it until I pushed it. All right, let's push it. So we copy that. The SSH one, please. Copy that. Remote add origin that. There we go. Git push. And now if we reload this page, one should see that it's now appeared, and we've got a check that is already running. So we can see whether it's going to build it properly. It started running. It's very exciting. Oh, we need to make it run faster as well. I'll put the acceleration link in later. Nitrex says, is it just imagining things, or did you change your name to Gerphy from Gerph? So in my in various social media applications, websites and things, they don't let you have a 5-letter name. So you can't use that. This wasn't the case here. Somebody had already got Gerph, I think. At least I think that's what the case. So I call myself Gerphy. There's 3 names that I go by online. So there's Gerph, Gerphy, and Gerphlut, depending on the limitations and whether somebody's stolen the name already. So generally my name is Gerph, but you'll find that I believe that Gerphy on some places. And GitHub, I managed to get Gerph. I think I've also got that on GitLab as well. So I've got things on there. Anyway, yes, so that may explain that, Alan. Were you always Nitrex 2001, or was it? Have I misremembered that as well? I don't know. Anyway, that is now built, and we got out of it a module. So yeah, I mean, it's unsurprising that it built because it's a skeleton. The whole goal of that is to produce something that just works for you. So, with that done, what was the thing I was going to do? What was the thing? Ah, yes, I was going to go to here. So we can go to settings, and we can go into the website. If we grab this URL, where was it? I've lost my blooming window. Is it this one? Is it this one at the end here? Is this one at the end? Dear me. There we go. Kernel inspection. Topic RISC OS. And space RISC OS 64 as well. There we go. 64, please. we don't care about packages or deployments. It's all good. So there we are. Right, so finished. Let's go home now. No. All we've done is create a stub. So all this does, let's just demonstrate it. Pyro dev common load module rm32 kernel introspection, and then drop to the command line. So all this module, all this new thing does is it goes and does print out a message, kernel introspection initialized, and then if you kill it, oh, no command line completion. That's annoying. I might have to add that at some point. We get kernel introspection dying. There we go. Very unexciting. Hello, Superior. Hello, Super. Nice to see you. So let us start out by doing some things. We've got a basic module that it starts up. So this is the code that's been generated. We've got something we can fill in. There we are. And we've got these bits here. And I've just updated this to actually include my usual debug code, which I forgot about, but I haven't actually exported it. If def debug define dprintf to be if one else. There we go. So now we can turn our messages on and off. I'm also thinking I probably ought to go and release the RISC OS project tool just because it's kind of handy, but I don't know, I'd be a bit interested. Sorry, it's Andrew. Oh, hi, Andrew. So people just we're just confused with names, I think, today. No, right, so we've got that. We've got a module that just does some basic initialization. What we want is some handling for the things that we are interested in. So should we start out with OS byte? We'll add the OS byte bits then, shall we? That seems like a good idea. So OS byte, how do we do that? We want to have a, well, put it in a new file. In fact, let's do all the handling for OS byte in OS byte. Here we go. So file name is OS byte. Implementation of the OS byte vector handlers. Date today, 14th of Dec 2025 still. And I want to include something like modhead.h, and well, I'm not sure what else we're going to need. We'll start out with that, and we're going to want to add some vector handlers. Here we go, vector handler. Okay, so we want a vector handler. So this is a vector byte v handler, and we need it to be parameterized because we need it to be error capable, which means you can return 1 or 0 to say you handle the vector or not, maybe specified in brackets in the form like that. So I haven't really made that clear which side you need to do it. I'm assuming it's like this, error capable, like that. I think that's right. Shall we see if that works? Build RISC OS. Simonj appears to be happy, so probably that's right. Expected a type found void. Declarative but found out. Have I like made a mistake or differing reader? Oh dear me. Let's make this a little bit bigger. A little bit bigger, please. Thank you. And F4 extern for. That doesn't look right. CMunch may not have been unhappy with it, but it definitely hasn't generated something valid. It'd be nice if we had some error handling for that, do you think? Should we try and put it here instead? I was very, very broken. Rebuild. Expected declare, so it found type. Found else. I think that's a completely different problem. Oh, hash else. Yeah, there we go. Try that again. Right, so we've got everything but the byte v handler now, which is good because now we can go and start implementing it. So find the byte v handler. Here we are. And here's how we actually should be returning it. Vector pass on, vector claim, or vector error is how it should be returned. So into the byte routine, paste that. And itchy nose this morning. And we're going to do vector pass on for now because we're not doing anything. What we do need though is a function that claims it and a function that releases it. So init. So normally when I do these sort of modules, I call things init and final for each of the modules, each of the source files. I think I'm going to do that. Yeah, because I could otherwise do claim and release to be clear about what's actually being done. But we might also have some initialization, so let's do it as an init. Description of the function. Claim vectors, vectors, and initialize state. There we go. And parameters pw equals module private word. Pointer to error. Or null if all okay. Kernel error. Init. We start right. And what we're going to need here is an os claim. We're going to need a variable to put that into, aren't we? Kernel os error start equals os claim. We want to claim byte v, and we want to go into byte v entry, and we want to pass in the private word. Return the error when it fails. So what we're going to need here, we need kernel.h. We're going to need studlib if we're going to return null from anything. We need some vectors, don't we? So include RISC OS /vectors.h. Yeah, that looks good. And then we're going to need another routine for finalization. Release vectors and shut down. Again, same parameters, so we can just do os release here. Now we don't have the os release and os claim functions, so we're going to need to import those from somewhere else. Really, I should probably be using oslib, but I've been implementing these independently. We can rework that later. I mean, that's just one of the ways I've been doing it. So I need something that will actually use vectors that I will have already have done. I wonder what we'll have. System vars doesn't use vectors. Oh, none of those use vectors. I think I'm going to have to look somewhere else. This is usually how I do things. I just go and find some code that I've already written and steal it, or write it from scratch. And it looks like I'm going to have to steal some code from elsewhere. So let's have a look in modules. Os commands won't be doing it. Anything that's got 2 on the end of it is probably readline will have done it. So readline 2, there we go. Readline 2 will have some implementation. And you go onto that window, that screen, okay. So if we have a look in here, we've got the OS module, OS interfaces. Oh, yeah, usually what I do is I copy the whole lot across and then edit it down, don't I? So claim and release, there we go. Caller vector we don't need. Read C we don't need. New line we don't. Do we need to print anything? I don't think we need to print anything for these ones. OS byte calls there. Nothing of this needs to be used. So all of. Oh, hang on. Don't edit the read line version. Edit this version, the version inside Introspection. There we go. And if not end if, no, because it's not a header file. That's all I need there. So save that and close it, and then we do the same with the header file as well. There. We don't need work. Oh, hang on, no. Copy across, then edit. We don't need worch. Get rid of the rest. There we are. Okay. So now, yeah, we've got the OS, we've got OS, and we'll need to include OS in here. Include OS. OS byte. Oh, that's still called init. That's not very useful, is it? And we're going to need to have a header for this as well. So we copy this and we create an OS byte file here. OS byte. I can do, yeah, this is this. If in a def OS byte h, line OS byte h. And we need kernel, don't need vectors, we don't need mod head, we don't need OS. There we go. And these are the only ones we're exporting. And byte handler is already exported in the module header. So that's cool. We can now go and add those files to the build. Oops, too far. o.os and o.os. Actually, no. Let me do this the other way. So I've not made those changes. Don't change. Let's get rid of my diffs. Don't need to worry about that now. RISC OS project update. If I look in it now, it's added the OS byte and the OS files, which is kind of cool. Only thing is it has reordered them, which is frustrating because OS byte relies on mod head as well, so I'm just going to need to add that to there. So that's quite nice. Yeah, I might rethink how I do that, but I can worry about that later. Right, let's build it and see whether we've got something that builds. See if we've got something that builds. We've got something that builds, but it doesn't do very much. So what I'm going to do is I'm going to steal my debug routines and put them into the OS byte source file here, and we'll print out a message when we get called. So OS byte called with R0 equals and I, R1 equals and I, R2 equals and I. This is why I'm suddenly thinking, is this how you write C code or is that Python code? I can't remember. This is C, thankfully. I was implementing the Hourglass module. So long ago I did an Hourglass module, and I've just made it work in 64-bit. And the Hourglass code is run on Linux, so you build everything on Linux by running a shell script that runs a number of different things, including ImageMagick and a bunch of other bits. Then it calls a Python program that takes the information from the images that were extracted from ImageMagick and writes out an assembler file and a basic file and something else. And then that assembler file is then assembled by the assembler, which is usually Objasm. In 64-bit, that's actually RISC OS 64 Objasm, which is a shell script that calls objasm to gas, which is a Perl script which converts the objasm syntax into gas syntax, and then it calls on to gas to go and assemble it. So running this thing, writing this code has been a bit of a nightmare, because I'm like, okay, I'm in the Python code that's going to generate the assembler, that's going to do this, that's going to... got very, very confusing. A lot of the time you don't care about the lower level bits, but it was quite fun, and it was making me really, really regret having written any assembler code at all, because I don't want to be writing assembler. But I have an hourglass that works in 64-bit now, which is nice. Inventing printf. Oh, I forgot to include studio. Silly. Include studio.h. There we go. Thank you. Right, we've got that built. So if we now go and load it, pyro dev command basic. Let's go straight down to basic, because then we can do sys os byte, oops, os byte 1. Oh yeah. Nothing to see here, people. Move along. I forgot to actually call the routines that are playing the vectors. If you don't call your code, it doesn't do anything. Os byte init. There we go. Error in there. Os error. If there we go. And we want to do a very similar thing down here for the finalization. Oops, wrong side. That side. Final. There we go. Right, if we try that again, this time we'll actually call the code we're trying to use. Strawberry Kitten says, am I a kernel wizard? I do a lot of things with the kernel. It's just in this instance I'm writing what will become part of the kernel. I've done operating system development for quite a number of years. Yeah, not for a while myself, but I've done it for a number of years, and so I'm relatively used to working with some of these things. Inventing, oh, I forgot to include my header. Include os.h. Somebody else asked something. Nutrex asked, are the hourglass size limits still a thing on RISC OS 64? So RISC OS Pyromaniac can handle any size of pointer. RISC OS 5, RISC OS 4, RISC OS 6 and all preceding versions appear to be limited to smaller pointer sizes. And the reason for that is a little bit unclear to me, but it's probably to do with how the calls are passed through to the pointer interface. The interface inside RISC OS Select was abstracted so that it was a little bit easier to extend, but still limited to 4 colors. That was a bit of a misdesign. I should have rethought that, but I didn't. Foolish. The restrictions on VidC are hard, and you can't do anything about it. RISC OS 5 also has, I'm pretty sure it has, but I'm unclear whether it actually completely works. It has a software pointer available as well. And there is no reason that that would have any need to be anything but completely flexible. So it does work mostly. That's good. I wrote a software pointer implementation back for Select on the assumption that we would need it for some graphics hardware, but it never really got very far. Well, it must be reasonably good then if Pinebook is using it. Yeah. The Spanner says that VidC has no vertical limit. Yeah, so there's interesting things you can do with the pointer. So if you're clever and you want to do something a bit special, you could actually have your pointer being really, really tall and then using that as part of your screen, but never actually having the pointer move. So your mouse would control something else. So you could actually essentially have an overlay, but your overlay is only allowed to be 32 pixels wide because Vidsi limits it to only 32 pixels wide, even if it goes the entire length of height of the screen. Spanner says Rasterman uses it for some cleverness. Yes, 32 pixels. That probably means it's just restricted. The Hourglass implementation, if anybody wishes to see it, RISC OS Hourglass Maker. Marker Maker. There we go. That's the one. French isn't protected. No, I don't care. So this has a separate branch for large hourglasses, which I haven't updated for 64-bit, but I could do. And this should handle that. So you could basically, it'll make the right calls to use larger hourglasses. However, it was not successful when I tried it. As Nitrex says, it's annoying, so it's impossible to redesign certain hourglass pointers due to the restriction. It is very frustrating. So if I have a look back here, there's a really, is it, which one is it? I don't think it's this one. Where's the GIF? Here we go. That one. So that's a really nice hourglass, I thought, and I wanted to make that into a RISC OS hourglass, but because of the 32 pixel restriction, I have to restrict it to just this center part here, and I cut off the end section. There you go. I think it's quite nice, that one. It would look really cool, particularly when it's animated properly. But the restriction from RISC OS means it's a bit more difficult. Since I can do that on Pyromaniac, maybe I'll go and make the changes to it, but the interface for setting the pointer shape is really ugly. It's an OS word call. My intent with some of the later work in Select as part of the graphics abstraction was to replace all of the calls to the OS word with a call to OS pointer, which goes through graphics V, video V, sorry. And then we could have you have a larger interface that was able to be called through OS pointer if you didn't want to use the legacy interface that was so restrictive, because it would also mean that we could use multiple colors, because if you've got a software pointer, you can have any colors you like, you can do anything you want, obviously restricted to what your current mode is. But time and energy meant that we never got there. Maybe in the future. There's some quite nice pointers here. There's another one here. What's that one look like? Oh, that's that one. I like that one. That's really nice, that one. I do like that one. Yeah. The hot point is crazy well, not good for 180 DPI. Really? That's frustrating. I mean, the whole thing is just dealing with any part of the system as an abstraction of VidC is the wrong choice. And when I did my video V implementation, that was one of the rare times when I actually just followed through and took the VidC implementation. I should have refactored it, and it's been a common thing for RISC OS 5 to just go, oh, that's what VidC did, we'll just abstract that and worry about it later, which isn't terrible in the sense of it gets you somewhere, but it is pretty bad in the sense of doing an extension to a system when you've got definitely other hardware coming. Anyway, sorry, got very distracted here. They're talking about hourglasses now when we should be talking about the kernel. Yeah. Let's make sure we actually include the header file, and we'll build that, and maybe we'll actually see this testing. Moving on. No, it didn't work. Why didn't it work? Inventing OSPI init. Oh, because I didn't actually include it. Yes, that's just opening the file doesn't work. You have to actually include the file. Make the changes. Number of parameters. Oh, yes, you've got to pass in the private word. Private word, and same goes for the finalization call. There we go. rebuild that, and then we can run our test. And this time we might actually see something. Woohoo! There we go. We've got some different calls being processed. Oh, that's an interesting one. R1 has a very big number in it. Well, I suppose it doesn't have to be anything. It could be just returned as anything else. Call R0. There we go. How's that for cool? Right. So quit that, and we can go and commit some code. Add ch. Oops. Everything. Added os byte, claim, and release. Oh, one of the things I'm doing there is I'm printing things out during the os byte call. That's probably not very safe. You probably want to be not printing out things during the middle of an os byte, because any of those printing calls could themselves call os byte, and then we get this nasty re-entrancy. Vector. I think that's all we need to say, really. Okay, so what are we trying to implement here? We're trying to implement 0 and 129. So let us have a look at what we've got. I'm just going to pull out the header for. I don't think we have a header for. Thank you. CD into RISC OS resources, export. Interface. Yeah, we don't have one for os bytes. Every time I end up having to use an os byte call, I go, oh, I should have defined that. And that's something I've cursed for like 25 years, I think, now. So what we'll do instead is we will. Oh, hang on, is it in RISC OS? It could be in RISC OS, actually. Let's have a see. Just cd to that directory again. Less RISC OS. I don't think it is. I think that's got a whole bunch of other things. Yeah, it's got the main swine names, and that's it. Oh, and the definition of what these OS ID is. And a reminder to myself. Ah, such fun. Keyboard status, buffers, some variable. Yeah, so it's not very useful in that sense. So what I usually do is, oh, I've gone to the wrong place. I don't want to do that. What I usually do is go into RISC OS Pyromaniac and pull that out. RISC OS constants byte. OS bytes, there we go. Because in here we've got all of the nice values. So we've got one there. And what's the other one? 129. That's hex 81. 81, please. Read keyboard. Because of course, read keyboard is how you get the operating system version. There are times when RISC OS's interface are a bit of a. Chris wants its kernel introspection code. So Archon Boundary also says maybe we need the kernel to pop up an hourglass. Yeah, because if you're implementing os confirm, you probably want to have a no. Confirm doesn't do the hourglass; just the pointer. Right, where was I? I'm losing my brain here. I'm losing my brain. Yes, I was doing this. So whilst I also remember, I'm in the wrong place. Hang on, did I just edit that file? Is stars in there or hashes in there? Oh, that was my fix from last time. I still haven't committed that. Oh, I must go and do that. That's not what I was trying to do though. What I was trying to do was this. And I was just thinking, sorry, my brain is going all over the place at the moment. All of these functionality descriptions here in the wiki are actually anybody can give me suggestions on this. So this is actually a in the RISC OS status 64 status repository. There is a section called features in the directory here, which contains all of the modules, and the idea is each of these will describe what features are necessary to implement the different components. And I think I talked about this a little bit at the big presentation I did a couple of weeks back. But if we have a look in the kernel down here, if we can find kernel introspection, this is the markdown file, and we can see it raw. You can see this is what's actually been described for it. And the idea is every time I remember, oh, I should do that, I will go and add a new requirement to the document, so we can actually remember what needs to be done and show progress. So if anybody does think, oh, this component needs to also do this, they can go and add things to it. And particularly, so kernel introspection, that's got a lot in it. If we go back here and we have a look at something else, here we go, file core. File core won't say very much. So functionality, it handles disk layout. That's all I've written because I haven't got round to doing this. But it does have list all of the commands that need to be implemented, SWI calls, services. But there's a lot of other things that file core needs to do that I haven't written the notes down for. So if anybody wants to do that, just like provide a PR or just provide some comments saying, look, this needs to be done as well, we can go and do it. Why are those blobs coming out as empty spaces? Shouldn't they come out as empty tick boxes? No, tick boxes probably don't work in here, but they get converted anyway when we go to the wiki. The wiki automatically does the conversion as part of the build. Anyway, hello Arctic, welcome back. And so why are we making our own kernel? So this is a quick review for anybody who else has joined. The whole the overarching part of this live coding is trying to make RISC OS run on ARC 64-bit ARM. And there is no kernel for it. All of the kernel for original classic RISC OS is in assembler. So we have to rewrite it all from scratch because we hate ourselves. Or we hate pastors anyway. So this is why I'm rewriting sections of it. Why is it 2025 and this still hasn't been done? Because nobody has felt that it is particularly important, and so it has been going that way. So the current bit we're doing at the moment is the introspection part, which is just basically reading information about the system, and all we're going to do is just stub it so that it returns dummy values, so it's safe to do. Alan has said, keeping the Hourglass theme going, there is a RISC OS module that's about 32 lines of assembly long. It just turns it on and off. Ethernet Hourglass or something? I don't know. There is one called Net Status, which listens for a number of service calls that are issued by the NetFS system, and it changes the colours of the Hourglass, and that's about it. That's as much as I remember on that. You'd have to have a quick look around and check, because honestly I can't remember. There's a lot of things I don't remember. So yeah, so what we're doing there was we're actually going to trap these two calls here, OSByte 0 and OSByte 129. So let's do that. this is the code over here we've got. This is our handler. So op equals reason. I usually call it reason because op is a little bit too short. R to R by naught. Switch reason case. Oops. Actually, probably got the beginning. Case. I've already forgotten it. OS byte read. No, not read. We've got read MOS version 0. And also the other one 129. Oh, not return, so we don't return it there, do we? We want to do R to R bracket naught equals something, and here we need to check also whether it's R to R bracket 0. Keep putting capitals in there, it's very weird. Naught and R to R bracket 1 255. Return vector claim, and the same will go for this bit here. I don't actually know what the return should be there, so I'm going to have to look it up. RISC OS PRM URL OS byte 129. Thank you very much. 129. To read the OS file is that, and if we're reading the OS identifier, oh, R2 is always set to 0 as well. Interesting. And those values there. So equals, oops, went too far. Oh, 1, sorry, it said, didn't it? R1 and to R bracket 2 equals 0. So what we're going to do is we're going to do OS, MOS, oh maybe not OS, MOS version. And this one here is RISC OS, oh I've still not named it properly, other one, that keyboard, there we go. And this is called the OS version. Really, this is not very helpful. OS byte 129 on what's it called? The BBC, is it MDFS.net? I think it's on MDFS.net. No, maybe it's not MDFS.net. Oh, it's the AUG. I can't look in the advanced user guide. What's it called in there? OS byte 129 and 81. I didn't find that either. And 81. Oop, lots of cases are and 81. Oh, probably not very helpful. 129. Read key within time limit. That's the one. No, there we are. If called with y equals and negative value equals keyboard scan. Hang on, you're not actually. Well, that's interesting. It doesn't actually say how to read the operating system version on here. Maybe it wasn't in the advanced user guide. That's curious. Anyway, that was not what I was looking for anyway. It was I was sure it was on NBFS.net. BBC Micro. Spro's not too bad. Stardot. Oh, this is very frustrating. Because usually when I search for this, it comes up straight away. Anybody remember where it is? Let's just search for it. I was sure it was MDFS.net. There we go. BBC basic RISC OS. Please not RISC OS. Actually, oh, Google search. Here we go. OSBite. No, let's look for OSBite. Okay, go on. No, we're transitioning between. That's not a helpful one. Oh, because it's not called OSBite, is it? It's called OSBite like that. No. BBC Basic. User guide. Documentation and resources. This is frustrating me now. Because usually, basic programming library, test programs. Usually when I go looking for this stuff, it comes up straight away, and it's clearly failing me today. Keyboard. OS version. Let's just actually search for the thing we're actually interested in. Maybe that's not what it is then. Toby Lobster. That's an interesting site. I've not come across that one before. All right, I'm gonna move on for now because I can't remember. Actually, no. What I'm going to do is I'm going to jump over here. Ah, yes. Because somewhere in here. BeebWiki mdfs.net. There we go. Got there in the end. So, it calls it machine type. Oh, OSBite 0. So what does 0 return? Identify host or operating system. Ah, okay. So we'll call this MOS. We'll call this OS type there, and we'll call this one OS version. Maybe we can't call it OS version because version is quite a. It's a machine type apparently. Because there's a lot in here, isn't there? RISC OS. So you've got lots of RISC OS versions here. So it looks like actually this will just need to be a new value. Are we going to go with AB? AB for RISC OS. Maybe we'll do that. We'll call it machine type. Yeah, machine type. There we are. I'm sure we can change that name. It's not going to really matter. Hash define RISC OS machine type OX AB. Fix me. Not documented. Define RISC OS. What was the other one called? OS type. OSBite 129 value. OS type OX. So this is the host or operating system type, and I assume we should just return 6 because it's a RISC OS. The implication is that this also controls the format of values and stuff. Thought FX0 did that info, but could be this one. Yeah. We're going to do 6 OSBite 0 value. Actually, this is documented because it's still RISC OS. Maybe I should put those in a special header themselves. Not sure. So, okay, let's do this, shall we? And if we now run it, oh, wrong window. Wrong window. Here we are. Into basic. OS byte 129,0,255 to R1 R2 R1 R2. Oh, sorry, that's not R1 R2, that's R2 R2. There we go. 174. So I'll just put that in hex. AE. Oh, that's not right. That's not right at all. Why is that not? That's why it's not right. R1 and R2 need to be checked. I'm checking the wrong registers. Build. Thank you. Unload. ARM32.kernel inspection. There we go. We now return AB as our operating system, as a machine type. Machine type, OS type, machine type. That is OS type. Have I got these round the wrong way? Machine type 29. This is the host system, which is not a host system. It's actually the operating system type, and that's not. Okay, Alan, what did you document it as? RISC OS byte 129. And when I say Alan, it's probably actually OS version. It's actually defined as OS version in strong help / RISC OS wiki. So, all right, we'll call it OS version. All right. It's an AB. Okay, and we'll rename it to OS version down here as well. Okay, so I've tested that one. Now I need to test the other one. Test OS byte 0. Ooh, that's interesting because OS byte 0. If we have a look at OS byte 0 here, it actually displays the OS value. We need to return an error. So we need to construct that, don't we? And actually, it describes it in here as a machine type. Right, I'm going to go with those terms. We're going to call it machine type here. So yeah, I know it came with a strong help management, but you have updated it quite well, Alan. So I think it's quite core to what we actually use. If the PRMs don't give us a good value, then the wiki is probably a good place to go from. So I'm going to go with that name. I've now gone through a number of different terms for this, and there we are. ARM-based machine is actually what it describes it as. They're all completely inconsistent. The strong help manuals I maintained for a little while, and before that they were maintained by Guttorm Vic, or written by Guttorm Vic. Actually, almost all of it was written by Guttorm, actually. So yeah, there's a lot of history behind those. So I've got this wrong, haven't I? Because oh, hang on, I just named the wrong one. I've changed the wrong one again. Oh dear me. 0 is machine type. Machine type. What's the hardest thing in computing? Naming stuff. With the second case as being dates. Right, so there we go, got that. But if R to R bracket 1 equals 1 to return the OS version, which gives us back in R's If it's 0, we return the OS version as an error block. Fine. If it's 1, we return the machine name. Anything else, actually, I think I'll make it return that because I think. So if R1 equals what equals 0, return vector error os version string. There we go. Otherwise, we return the machine type. The machine type needs to come out in R1. Okay. This isn't painful in the slightest. Dum dum dum. Yeah, that looks right. Oh, I need to actually define it, don't I? So static const underscore kernel os error what was it called? Os version string equals bracket. Ooh, what error number do we normally return? That's interesting. Pyro dev DOS. Error number F7. Error number underscore, I'm guessing it's OS version or something, I don't know. Should probably put these on a new line. And message, let's keep it to the same structure. Actually, that's a very good point. Conf 64. What do I return on RISC OS 64? I think I put. Oh, apparently I don't put anything extra in there. Fine. Not going to do Pyromaniac. Module and full version and date. How's that? Probably going to be okay. Oh, in fact, why not? RISC OS 64 variant. Just so we can tell. I need to include mod head. I did include mod head. Version num, sorry. Version num. Oh, I need to know what that OS version thing is there, don't I? RISC OS kitten, new errors, grep for F7. Okay, F7. Huh. Really? How strange. That's very confusing. Why is it not? I don't know why that is. So this git lab dot RISC OS open, not the WIMP. Kernel PMF. Oh, sorry, not that wasn't right, was it? Yeah. Kernel. I want to go into the directory PMF. Sorry, SPMF. OSByte. OSByte 0, please. Is OSByte 0. New FX0 error. Ooh, that's exciting, isn't it? They return it from the ROM trailers. That's interesting. System name, vstring, error number FX0. I don't remember seeing that in there. Let's have a quick look. FX0. Nope, not in there. So I'm going to have to find it in. It's quite interesting that that's returned us that. Nice to see they've actually included the table from BeaveWiki. I'm pretty sure that's because I mentioned it to them. Okay, so we're looking for. Ugh. That's not very sensible. It should be hard coded. Although it's actually the version of the yeah, it's not a bad idea actually. Yeah, I take that back. It's probably not too terrible. Although having it as a variadic string seems a bit weird. Anyway, forgotten what I'm doing. Yes, in order to find out what that value is and just confirm it, we need to have a look in programmer/header source. Unless they've moved it. They haven't moved it. Header, new errors, please. New errors. FX0. 247. Yeah. Bad BBC bad hex. So yeah, bad file system name. Yeah, it just ends up skipped in this in my version. Wonder why that is. It may not have been defined back on RISC OS 4 days. So yeah, not bad. Hang on, it actually looks like they've defined every single error here. Maybe not every single error, but many of them. Because if I have a look in header : interface.new errors. Oh, I don't know where it is. RISC OS shell. RISC OS resources, export header, interface, new errors. It's not in new error interface. Why is it not in interface? Is it in global? It's in global. Interesting. Yeah, lots of history. Lots and lots of history. Go back up here. Yeah, so old errors here. The old file used to only contain this few list, whereas the new file has got loads of them in, which is quite amusing. Yeah, it's a bit strange that. I mean, maybe that was done so that there was a way to ensure that things were kept working. I did do similar and define new things going backwards, but anyway, the point of that was it is error code F7. So let us go and define that. And it's called FX0 apparently. So let's define error number 0 is OX F7. Oh, we can make that a bit smaller now. Rebuild. It's going to fail, isn't it? Illegal cast to int at line 92. Yeah, that needs to be ampersand there. Thank you. So let's try this again. Go out of here. Pyro. Oh, come on, brain. Pyro, come on. That one. That's the one I wanted. Right, star FX0. there we go. We're now returning an error. Star fx 0,1. It calls it, but it doesn't actually generate the error, which is what you expect. And if we do an OS byte here, we can see 0 gives us an error, 1 gives us value 6. Okay, cool. Add some notes. On RISC OS 5, this string is constructed from the ROM trailers. On RISC OS Maniac, it is constructed from the build version. On RISC OS for this select, I don't know about for select, this string is coded into the utility module, and I think that's true of all earlier versions as well. So for now, that's fine, because what we can do is we can just change that implementation. Dead easy. Okay. A lot of work to get like very, very simple call implemented, I think, but it doesn't matter. And I've renamed those variables about 12 times now. Implementation of the OS byte information is now complete. Implemented values we're going to return. End of story. Push. Right. So having implemented that, not system vars, go away. Not debugger. No, no. That's a useful one. That's probably not useful actually. Don't care. That was Winpost 6. That was the, lots of bits here. Clean up, clean up, clean up, clean up. Templates, don't need that. RS Maker, don't need that. Don't need that. Introspection, here we are. Now we've got our module. Okay, so we probably want to put some tests in to show that this is working. And how we do tests is we pinch the implementation from the last thing we did. So WIMP templates, because we know that that was working. I mean, it's a bit weird how it's done, but we can handle it. So test data here. Nope, don't want that. How does it work? Oh, we didn't actually do the testing bits in there, did we? No, we have to go back to system vars. Go away. Bye bye. System vars. There we go. Test code. Here we are. So we want to make file, git ignore, test script, some things to do processing. Yeah, that's probably over test program as well. A separate set of tests, isn't it? Okay, so then we need to pinch the bits from Pyromaniac. So that bit's now done. Now we need to grab the bits from Pyromaniac, which do similar. So dot test code against ./Pyromaniac test code. Pull that back up. Tests introspection and S code. What tests do we actually have in the introspection? So we've got testing for OSByte 0, checking that OSByte works. We can lose that. Actually, that's probably a good test to have. Good test for that. Don't need the system, the CPU stuff. And then we get into some of these other bits here. So we'll just disable all of those. but everything else can be marked as okay. All right, so the bits we need is OSPite 00, OSPite 100, and 81, and we'll be done with that. So in the S directory, OS 000, I've missed it, OSPite 00, 100, and 81. But what's 86 do? Not sure what that does actually. Oh, I think that's character position on the screen. Fair enough. And 75. VDU status. Don't need to care about that one either. Right, so that'll get us the basic information that we want. So close that now. And refresh the directories. Some test code. Test introspection, that needs to be called test introspection pyro because we're going to convert it. And the test we're going to run is not the system variable tests, but the introspection tests. So the reason that I'm using the RISC OS Pyromaniac test code and trying to make it all work the same way is because that code already exists. It's pretty dumb. As you can see here, it's not actually doing very much in an exciting way, but it does give us a useful basis, and it's already been written, so yeah, we can do that. I want to disable all of these. Is it disable? I don't remember how to disable some things. Capture, argument, expect, replace, removes. Disable, it is disable. Just put not implemented. Or did I put NI last time? I think I put not implemented, it makes more sense. And then we can remove the disable from the ones that are working. So this one's good, this one's good, this one's good. I can't reconfigure things. Not Pyromaniac only. There we go. And then all the rest will be disabled. Yep, they'll all be disabled. Okay. So that's that set up. And then I think we just have this bit. This is the magic stuff that does all the building. Module is not system vars, it's kernel introspection. We don't need this system vars 32 thing. Yeah, let's see what happens when we do that. Shall we? Test code make. Oh, I needed another file. I need some headers, so let's pinch those. This one here, headers, swize. We're probably also going to need macros as well, aren't we? Print macros, macros. Yeah, that probably does a good job. Right, see whether that was sufficient to make it work. Directory doesn't exist. Mucdir bin and mucdir expect slash introspection. Hello, RISC OS UK. 10 people watching now. Woo! Really exciting. We don't have a big audience here, but that's fine. There we go. We built a couple of things. Excellent. Good. So now make tests and see whether we actually work. There we go. No rule to make target sysvars. Well, that's true because we don't want to run with test sysvars. We want to run with kernel intro. Oh, it's just called introspection, isn't it? The other advantage of doing it this way is that once the test code has been written, extending it is a lot easier. There we go, we're now running stuff. Well, hopefully we're running stuff. It's firing it off at the build service. Can't read replacement file. Okay, you're quite right, we need that file. And I'm just realizing that, of course, this is going to come out differently. So we're going to want all of these files here, because those are the expected outputs. And what was the thing that was actually complaining about? 00 replacements, and I've copied that over, so that's okay as well. Right. See whether that works. Probably won't. I imagine something in here we're going to get. Oh, yeah, we've still got things referring to this. It would be nice if I made this test framework a lot more friendly, so it wasn't too hard to use. Just do comment FFC, do that. Might be easier, mightn't it? And all the test data. Yeah, that sounds good. Yeah, so what we failed here, YAML command not found. Oh, that's because I edited it whilst it was being used. Yeah, lots of problems with it. Oh, it's still trying to run these. Why are you trying to run those tests? That's not right. Disable, not implemented. It should have disabled those. So. Oh, hang on. There's a second group. There's a second group down here. That's why. Need to disable that group. The disable on a group definition only disables that group, and then the next one you have to put it into the next section. Let's just rerun those tests and see what happens. Come on. Have you gone and crashed? Have we broken this build service? Build up RISC OS online. That seems to be working. Build. Yeah, that's running. Okay, let's run it again and see whether it had stalled or something. Oh, there we go, it's working. File, still got another one in there. This is not very good, is it, when I'm having to change it all the time? Oh, that's because down here, yeah, I explicitly said load system files. Kernel Introspection. This should all be parameterized, and we should have it a bit more flexible, but I've never got around to it. Maybe I'll have a look at it later and have a see whether I can make a more general plan for that. Oh yeah, I've got all the other debug left on, haven't I? That's not going to make it very happy. Yeah, that's not going to make it very happy at all. Let's turn the debug off. Have a break very shortly, and fingers crossed we'll get this to the point. It's still running those tests. Why is it still running those tests? Did I? Right. Find me a group. Memory physical table. Missed that one, and I think I edited the wrong file. I think that's why it's gone wrong. Okay, make. There we go. We built the module. Run the test code. Oh, so make tests. Right. So what? Still telling me it's got the version numbers wrong. So I need to go and make it just ignore those version numbers. So if we have a look in the expectations here, this is actually oh dear, I don't want any of those memory ones in there. RM expect introspection memory, all those can go. In the replacement, so this is a script that we use to sort of normalize things so that they're a bit more sensible. So we don't have to keep changing them every time round. And basically this is tailored for RISC OS per-minute, but for this code we actually want to get rid of everything that's inside the square brackets. Just get rid of that. And any spaces leading up to it, so get rid of that lot. And we really want to go and change the RISC OS any number point, any number. We want to replace that with RISC OS v point bv. And we want to get rid of the date as well, don't we? Because otherwise it's going to change every time. So any slash bracket date number A to Z, and then 20 and 23. Let's leave us safe for the next 80 years. 0 to 9. There we go. And that can be, oh, remember the bracket at the end. And that can be replaced with DD MM. There we go. So that should make those ones come out sensibly, I hope. Just run it again and see what we get out. I think I'm going to make it a bit bigger so I can see what I'm doing better. Unmatched bracket. Oh, open bracket there. Close bracket. Did I forget? Do I need to escape it as well? I think I probably need to escape it. Yeah, that's probably all it was. Let's try that. Right. Maybe replace the bracketed text not with something like bracket qualifier. There we go. So it actually look a bit more, we know that there's something in there. Okay, so that looks okay, that looks okay. And this one's returning AB, which is actually correct for this operating system because that's what we've returned. So, just refresh folders, get rid of this one as well. We don't need the configured version. Okay. I think this is going to be the one that I'll say these are all good answers. Yep, that looks like a good answer. So sorry, I've skipped over this, but this is a diff format. So minus means that's what was there previously, and this is what we were expecting, and this is what we got. So all of those look okay. And if we have a look in these files now, this actually shows us this is what we were expecting, and this is what we received. So I will go and rename all of those files so that they come out the same. We do rename -F. There we go. And if we refresh that again, they're gone. Awesome. Right, next thing is I want to be able to add those files to the repository. Everything that's in here, in fact. Status. Ooh, lots of tests. Oh, except no, get rid of underscore tump. Blah, that we don't need that. I think that's all needed. Yep. Okay. Status. And then we just need to make it run. And the best way to make it run is to pinch the code that makes it run from. How do I get a new window? New. Oh, there we go. The one that was in system bars, because in there we knew we were running it on. Ooh, issue template as well. Ooh, I can copy those across. Is that just, that's just the version number. I should really update that in the template. Test the module, unzip it, and then run it. Okay, so unzip it, give it the right name, move kernel introspection to be. And then run the test. Looks okay to me. Okay, commit as a. Add tests for the boss bite. Introduction, introspection calls. Do not regress. Push. Oh, hang on. No, before we push, in RO build, we want to have this thing, which makes it build fast, and that will make it. Ooh, yeah, that's a good idea. So, make the module. That's a good one to have. And we could do with loading it just to prove that it does load, because there's no point in going any further if the module doesn't even load. Kernel introspection. Ta-da. Okay. Yeah, I think that's good. Update the build. CI rules to load the module. Load the module as well. Check that it's working. Push. Okay. Now we get to see whether it's actually doing anything good. Here we are into the actions, and we'll have a look at what we've got. Dum dum dum. Built the code, it loaded the module, it was apparently successful. Now we're running the tests. One test successful. Two tests successful. And 3 tests successful. Whee! Okay, that was highly exciting, wasn't it? But point of that was, oops, status even. We now have the Allspite introspection calls implemented. Okay, so it's literally just returning some static values, but they're implemented, which is what matters. So I'm going to take a short break now that we've got that bit done, and then we can hopefully go through the other bits. RISC needs a different way of claiming its call because it's actually a system call. We have to trap the system call directly, and the same goes for some of the others. But we'll do RISC first, and we'll see where we can get to with that. Excuse me. Right, that's where we'll go to next. about 10 minutes, I think. I'll see you in a bit. Bye. What do I do now? I press that. Should we try that all again? This time with sound. Yes, so what I was trying to say was that I've taken the opportunity to catch up on the advent of compiler optimizations from Matt Godbolt. As you can tell, he's a Brit as well, which is he goes through various optimizations that the compiler provides for you, and he's been working through this all Christmas. It's been a lot of fun. So yes, I've had a chance to catch up on that. Do watch it because it's a lot of fun. At least it's a lot of fun if you happen to like looking at various compiler and low-level assembler things, which I do. So there you go. Anyway, that was my part of my break. So before the break, we were implementing the OS calls, these two here, which we can in theory tick off now, which will tick off everything at the end of what we've done. And yeah, we've implemented those just to give us a very, very simple set of version numbers, which is cool. Next thing we want to do is to have a look at read_sysinfo, which a lot of this is going to be pretty much redundant, but we just want to be able to get some information out of it so we can actually return things. And to do that, we're going to need to trap os read_sysinfo, claim that call, and hopefully we'll be able to trap that. Mossabdia. Can't pronounce that. Apologies. Very, very quick summary. The general project is to convert the RISC OS operating system from ARM assembler to ARC64 assembler, and we're doing it by converting things to C code. And the process of doing that is somewhat tedious, but that's life. At the moment, I'm doing part of the kernel code that just does reading information about the system, and it's all very, very simple. We're not doing anything particularly complicated or anything. We're just trying to get back values, but doing it in the same way as it did previously, and then testing it and making sure it works. It's a very, very long-running project, but this small part of it is documented in the page on the RISC OS 64 status wiki, which is linked at the top of the chat. So hopefully you'll be able to see what's going on. It's all right. Don't worry. It's absolutely fine if you're not understanding things. I hope it's interesting nonetheless. Happy to try and explain things when I can. So, yeah, trying to implement this read_sysinfo call. The way we're going to do that is we're going to steal it from code we did a couple of sessions ago. So we're using the system variables code because that already had some handling here. So if you were following that, you'll remember that we have the oswise functions here, and those provide the ability to claim system calls. And then within the module, we provide those system calls. So in the module here, we want to steal the relevant bits of that. What do we want? We want to register oswise. We want to steal that bit. Let's put that down here. Ooh, looks like we don't actually have any error handling here. It's not great, is it? Maybe we'll add some error handling as we go, and then we can update it later. Oh, there's this declaration of the oswise there. Shutdown is here in the finalization code. That's really not matched up very well, has it? Stick that there, thank you. Reload the page and it'll make it a bit nicer for us, hopefully. Yeah, not so great, but it doesn't matter. And then at the bottom we should have the actual, here we go, here's the registration of the SWI calls. Steal that as well. Right, so now we need to actually implement them. Close that. And then go back to the header file to add in the interface level code. Excuse me. Modules wise, let's give it a different number. Excuse me. Oh, apologies. Oh, horrible sneezing. There we go. There's elsewise. We should give it a different error SWI base. These are just dummy ones, so it doesn't really matter what they are. 900 there. Error base. We'll stick an set of errors in here, and we're going to want something for. Oh, we certainly want a not implemented error. So let's just provide a not implemented one. Not implemented. Not implemented. Ooh, too many letters in that. There we are. There we go. Bum, bum, bum. SWI decoding. Here we go, one of them as well. Although we're actually kernel introspection, and the SWI calls are going to be read sysinfo and read sysinfo there, and that's the only one we're actually handling. Oops, that wasn't what I meant to do. Go back, thank you. For now, because we'll do the other ones as well, but for now that's the only ones we're doing. And then we want one here for read sysinfo as well. Ooh, too many letters that are wrong there. Read sysinfo, and then we don't need that. Okay, anything else? There's a command there. That's all good. All right. So changes, good. OS-wise, and I think that didn't actually do anything else, did it? It's just called Swix, yeah. Okay, we think that's all right. So now let's just update the make file. Ooh, RISC OS project update. I can remember to use that rather than manually editing it. RISC OS ammo. Okay, I forgot to copy the header file over. Header file, there we go, over there. Okay, we built something. We built something that actually works already. That'd be quite impressive, wouldn't it? Surely not, actually. Kernel introspection underscore read sysinfo. Yeah, that wasn't complete. I didn't think it was. Let's clean things, and then we'll rebuild, because probably it's just some we changed files and it's not actually built everything. No. Surely that should. Oh, I didn't update the make file. Yeah, normally I would have updated the make file by hand, and I would have spotted these, which tell us that we've got to have the different types of module things. So yeah, that's where I went wrong. Okay, that's fine. So let's do a clean and rebuild again, and then it'll tell us it's broken. You may have noticed I'm using make or RISC OS ammo. That's because I've actually got make is which make. There's a special script I've got here which tries to decide what type of make you're using, whether it's a RISC OS make file, and if it is, switches into RISC OS mode and calls RISC OS ammo instead. So I can type make when I didn't mean to, and it will still do what I wanted to do. So it's just one of those little nice to use features. what's it called? Quality of life features. That's the word I'm looking for. So when we build this, we should have some problems. There we are. We've got bugs. Inventing read var val and set var val. Apparently, I'm still referring to those. Let us fix that. Read var val. Should be read sysinfo. Info. My fingers were one to the side, and we want to call into the SWI call for read sysinfo. And the same goes for this one here. Okay. Although I'm claiming the SWI calls here, when this is actually in the kernel, you wouldn't have them as claimed calls. They would actually be just in the kernel. So that's not a big problem. It's just that this is how we make it work when we're not inside the kernel itself. So we've now got this implementation working. We now need to actually, this header file should now be working. Looks like I missed one there. Was that in here? Did I have another read var val? Entry read. Oh, that's why I did it wrong. Yeah, got the I typoed that. I'm going to create an os read sysinfo file here. Os read sysinfo implementation. Date 14th December. I meant to learn how to actually make it automatically enter the date in there because that would make things easier. I just haven't learned how to do it yet. There's a special thing in Sublime Text that will actually do this. So if we go into the header for the module, we should have SWI read sysinfo. This one, that's the one I wanted. Pinch that routine, put it there. Include mod head. Probably also want to include studlib as well. Oh, and probably if I include studio, I can then put me debug things in there, can't I? Pinch them from here, like this, and put them there. Okay. Return not implemented. And RISC OS project update. Excellent. Now do the command again. We should see that we can actually call the system call. Basic will not run on a pre-RISC OS former ship. Oh, you pain in the behind. What? The version of Basic that I've got built has the protection in it. That's a stupid thing. What's happened is, because I've changed the kernel introspection values, Basic no longer runs. Right. That's somewhat annoying. Let us turn that off. Modules, which were Basic, in fact, that's what we want to be. It clearly heard me talking. I suppose with AI around these days, that's actually possible. It could hear you talking and know what you wanted to do. That's terrifying, isn't it? Right. How do we configure this then? Is it in the make file? No, it's not configured in the make file. Is it configured in which file do we go to initially? Module AB. Module AB. Looks like it's probably in here. So somewhere in here there'll be a conditional prompt variable. Yes, new one. WIMP mode for mode. RISC OS 4 only. That's the one it's got to be, isn't it? Ooh, that's not what I want to do. There we go. Turn that off. RISC OS ammo. Copy im32/basic into projects. Yeah. So those are my, or were my parents' cats. There were a number of kittens that got that adopted my parents, and Dad got a lovely picture of them one day when they were sitting out on their wall. It's very cute. So yes, that's what I have on my things. Sorry, I can't help control your speakers, I'm afraid. Projects, Pyromaniac, modules. Sorry, RO, Pyro. Modules. Basic FFA modules. Yeah, so copy it to there, please. Okay, diff git commit. Allow basic to run on non-RISC OS 4 systems. This is making sure that it will actually be built into my build environment in the future, so I don't get bitten by it again in the future. Come on. There's a lot of submodules in this repository. Oh, it's taking a very long time, actually. Come on. Okay, well, I'll come back to that later. It's not an important one. Oh, there we go. Right. Update basic to allow. Working with. Strictly, I should now test that it works, shouldn't I? Otherwise, it's not a lot of use. There we go. Yes, so that has fixed it. Thank gosh for that. Right, and then we should be able to call it's not implemented. Excellent. Right, let's start doing some implementation then, shall we? I don't need basic anymore. What I do need is to start implementing read sysinfo. So let's do hash include riscos /os read sysinfo.h, and if we do riscos kitten sql h dot riscos h dot read sysinfo. There we go. Lots of things. Lots and lots of things. Yeah, actually grep fine. There we go. Those are the ones we want. If I just select all of that there. Right, we can see them all now. Which ones do we want to do? So, reason. Art R0. Don't care about that one. These are all the reason codes here, all the way down to debug info. Apparently I've only got as far as this one. There's some extra ones that are implemented in RISC OS 5, which we don't support, or won't support at the moment. So we'll just go through these ones for now, and then we'll work out what we can do. So, switch, reason. Okay. Here we go. Case. One. Break. Anything else we can do commonly in those? I don't think there's anything else we can do that's common. No, I think that's probably all right. So, this lot's all related to the chips and unique ID. Oh, loads of them. I'm not sure this is going to be the best way of doing it, actually. I was thinking I'd go and do it by implementing it just by deciding on each of them. But I'm wondering now if maybe I should actually just pinch it from Pyromaniac, because I've already worked out what I should be doing there. And that would make it a lot easier, rather than having to work out the values for this. I mean, so kernel value, all of this implementation is going to have to just go, because no, we don't implement congruent collusion. Oops. There is never any collusion in RISC OS 64. Return equals not implemented. We'll always just return an error for that. Should set the error at the top, shouldn't we? Oh, I know what I should have done. Yeah, I should have put these all into functions, shouldn't I? Yeah, oh well, doesn't matter. Platform class and ROM information. Okay. And of course the default will be not implemented. Turn the error. Okay. Probably should start out by setting it to that, shouldn't we? Because if we fall off the end, then we don't want to be leaving it invalid. There we go. All right, so let's read sysinfo number. Easy. Okay. Now I'm going to comment all of these out in here. Okay. And hit another one there. Just yeah. Oh. I could have got rid of the things there. Oh, all right, I won't do it that way. I'll do it this way instead. Because I think I was going to get rid of all this code in a second anyway. And just replace it with how Pyro does it. But we will see. We'll just have to see what we've got. There's not a lot of point in trying this out and not finding the right code for it. So let's have some implementations here for the same things. Got one too many there. Kernel OS error. Star read sys info. Oh, something dinged. Yeah, wasn't important. Oh, it was important. Yeah, we haven't got Dave here today. He's having problems. Dear me, not great. Read sys info. That's a good function name. Is it that? It's that. Good. I'm going to pass in swyregs are there. Oh, cannot type. Return. Alrighty. So this should be relatively easy to just. Oh, if I'd done it when I originally had this, it was more easier. Equals read sys info configured screen size. Oh. Mode. Yeah, so all of this, my pasting of these in was rather redundant. Doesn't matter. Oh. Don't want to be sneezing anymore. Yeah, we can just get rid of these because actually, no, what I'll do is I'll move them. No, I'll just get rid of them. I don't care. Yeah, that was a waste of time. Not oh, I copied the wrong thing. So that's the other thing of watching Matt's advent of code things. You realise like that. Oh, that's actually quite a prepared and well written presentation. Whereas mine are like, yeah, just do any old thing. It's fine. Admittedly, he did know what he was doing, so yeah, but. More unique ID, never implemented. Actually, I'll call it, but we can because although this is actually intended for RISC OS 64, we will need one that handles it from the non-64 case. So yeah. Oh no, I didn't mean build. Oh well, it's fine. Serious anything? I think that's just the odd build information that we've got here. And version. Debug information, right, so now we've got a separate function for each of these. And apparently I've got a missing semicolon. Oh, I put a colon rather than semicolon there, that's why. That's good. Right. So let's see, remember what I'm trying to do, which was edit Pyromaniac. Oh, let's pull the whole thing up, it'll be quicker. look for read sysinfo. Where's the implementation of that? .py. Not wimp read sysinfo, os read sysinfo. Oh, that's the constants. No, I don't want the constants. Got T in there, that's why it's failing. Come on. If I put os at the beginning, does that help narrow it down? Maybe it's not called os read sysinfo. There it is. Yeah, right at the top. That one. Right. So there's a whole load of configuration because you can reconfigure how parts of this work. Here we go. But the handy bit we'll have here is we've got the comments as well. So let's bounce that window to the right, this window to the left. Make the editor area a bit bigger. And we can just cut things out. So in this code, we actually register all the routines and then they end up being dispatched to there. Here, I've actually put them in directly. We could actually have a dispatcher. We could have a little array that contains the reason codes and the dispatch routines, but I've done it this way, fine. It's not the end of the world either way. So let's have a look what we've got here. So configured screen size. Let's have a comment that describes it. There we go. So configured screen size is 0. R to R bracket 0. 0. Fix me. Read the configured size. No. Actually return because we've got no error here. This is all good. That is now an implemented function. Configured mode. Here's the definition. We're just going to again return some constants. Here we'll do R to R bracket 0 equals mode. We'll just return 27. Read. Oh no, I didn't mean that. Type and sync. Oh, not 0, 2, sorry. Okay, chips and unique ID. Next one. Ooh, yeah, lots of stuff there. That's much more fun. In fact, let's copy the whole lot. Whoop, a bit too far. No, stop it. Ah, I'm not used to this. Right, I've changed the configuration of the cursor so that the cursor will always try and keep 3 lines at the bottom of the screen. But apparently it's really hard to actually do a dragged selection with that setting set. That's annoying. Yeah, Oh, damn it. I might have to go and like raise a bug on that because it works really well for my for keyboard operations, but for that mouse operation, that was clearly insane. I was bouncing around all over the place. Right. Yes, there's lots of things here. We're just returning, setting values to. Say null, not none. I'll make this. Yeah, that looks okay. So there'll be some bits here that are a bit wrong. What we'll do is we'll implement some of these, this information later. But a lot of it's going to be just like, leave it exactly as it is, and we can then fix it up at a later date. Because it's not important that everything works perfectly, but just that it actually returns something sensible so that people can start using it and we can start filling in the correct values as we go. So next one is I/O features. And all of this will be dead for RISC OS 64. Nothing provided. Realistically, all of this should be returned in a table or decoded from a table, so we can actually return useful answers to the user. No, come on. Into there, please. Yeah, some of this is going to be rubbish. Ethernet address. Oh, that's going to be MAC address. Yeah, there we go. It's not particularly interesting either. Didn't want that there. Put it there, please. What was your favourite RISC OS machine? RISC PC was my favourite. I spent a lot of time working with the A5000 because we had one of those. It was nice, but it was just so limited. I would not want to use it again. So a really, really difficult. What machine do I have now? You're looking at it. This is my RISC OS machine. I have a Mac. I don't have a, well, I do have my old RISC PC. It's sitting in a box down there. Well, sitting in bubble wrap down there. But I haven't turned it on in 15 years. It almost certainly is dead. I really should have taken the battery out of it because it's almost certainly killed the motherboard. But yeah, I don't have a RISC OS machine at all. I only have RISC OS Pyromaniac and RPCMU. Nope, no, the battery is still in there. I keep saying, oh, I'll go and do that, but it's long gone now, I'm sure. So it'll have eaten through parts of the motherboard. And also, yeah, there's no need to use it. The only thing that would actually be useful about it is the viewfinder, I think, because a RISC PC with a viewfinder is quite good. If you fancy having a go, that is fine, but as I say, I'm not especially fussed with it. It's almost certainly eaten through a good chunk of it, which is a bit sad, but that's life. I mean, there were other machines that I used. I had used 3020s, 3010s. Neither of which were particularly nice. When I used to go down to school to help out, I used those. But yeah, it's not they're not particularly great. 2001, the Castle Kinetic card was actually quite nice. The amount of hacks that went in to make it work made it a little bit sad, but it was reasonably well thought out. Yeah, there was quite a good job that Matthew and John did with that. I mean, it's a it's a computer on a board that then interfaces to the rest of the RISC PC, which was quite fun. But the Kinetic is yeah, something of a special machine. Oh, special upgrade. This is the same. This is the unique ID. So I think these unique IDs are the same. I'm not quite sure. Oh, it's the raw one. So one of them forces the identifier to be Acorn and the other one doesn't. This should not be implemented for RISC OS 64. It will need a 32-bit implementation though. We'll just leave that for now. We can put the interface in, but that's it. I'm not even going to start looking at that one. Single value question multiple. Oh, I could potentially actually implement the multiple read values interface there. It's nasty. It's just nasty. Aborts. So the abort address stuff is actually quite neat. It's quite nice. Probably shouldn't be in read sysinfo because it's a dynamic one rather than a. It should be something potentially should be in change environment or something like that. I think. I don't think it should be a read sysinfo because read sysinfo should be static information or has generally been static information. Right, platform class. Now this is a biggie as well, isn't it? And we've got a bunch of extra flags in it, so we can fill that one in when we get there. Yeah, it doesn't look too bad. ROM information. Now this will have a completely different implementation for many of them, but we can do that one relatively easy by just providing a separate function call that actually returns the data. And then read OS version. Lots of info in that one. I obviously lifted that in its entirety. Yes, this was intended so we could actually get a better set of information about what the kernel version was and the other parts of the system. So yeah, let's copy that code, comment it out, so we actually know what we're trying to do there. Of course, system init doesn't exist. HAL version would be the relevant thing to do there, if you were like trying to do it as a compatible type of interface. Sorry, just looking over here. Is the reason why RISC OS was never moved to a disk-based system? You mean booting from disk rather than booting from ROM? I suspect that's just legacy. People had this continuing idea that we must do it in ROM and have it bootable because then school kids can't go and get it to a point where it can't boot or whatever. And that seems to have persisted. It's just stupid. There was work in the select time frame to produce a micro RISC OS, basically. So you had just the kernel, C library, basic screen I/O, color trans, not the font manager, and then the file system, with the intent that plus loading from disk, you could then go and boot off the disk without having to do anything else. So you basically just have file core and a few other bits and pieces. But the difficulty was you'd need to boot something else. And if your file system was different, or you wanted to boot off a different system, you'd still have to have all of the podule interfaces. The podule interfaces might need other components, and it started getting quite big quite quickly. The real issue is that, of course, that there's no BIOS, there's no boot environment to set the system up, and therefore that's not just RISC OS, that's ARM in general just has not had a standardized way of booting systems, unlike x86, which has had the standard BIOS, and moving later on to the secure booting thing that I can't remember the name of. Yeah, doesn't matter. But it just hasn't been set up, and there is a, I want to say really good, but it's never really good. There is a rant from Linus about how ARM should just basically or ARM people should get their shit together and not have UEFI. Thank you, Alan. They should get their shit together and try and actually have a standardized way of booting. Both, yeah, all of you going to get it. Thank you. Sorry, I only saw Alan, but Dave got it as well. See, my bad explanation, people know what I'm talking about. But yeah, they just didn't, and there's this whole mess of things, and every system seems to boot in a different way, which, yeah, it's a more immature system, and they're all embedded restricted systems, and embedded systems, yeah, nobody cares. Some systems you call Core Boot has now started to take over for a lot of it, and I believe with the ARC64 it's a hell of a lot more standardized. I have yet to have a look at that area of things. Probably February or March time I'll start having a look at that and seeing how that could work. It isn't actually in the plans for the on the wiki pages, but it's around that sort of time that I'll start looking at the what we need as additional components to get a bootable system. But most of this is not based around physical hardware. Yes, Dave got it as well. I'm sorry, I looked down and the last thing I saw was the one from Alan. It was Dave got it first. Right, so I've now got comments on every single one of these that I have provided, which is good. So what we can do now is we can try building it and see where it all breaks, because it will break, because I've not actually implemented any of these things right. And I think I've still got a whole bunch of Python in there as well. It's nice actually having people ask questions and suggest things and remind me of the words I've forgotten, because then I can at least look at it and go, oh yeah, I got that wrong, didn't I? It makes things a little bit easier for me. A second. And it also means that when people watch these in the future, hopefully they'll have an idea what's going on. Right, so these uint 32s for everything, I think. Uint 32s all around. This one's, oh, and semicolons on the end of them as well, because this is C, not Python. I have some cunning ideas about how to do modules in the future. But largely they're down to me having some time to experiment, and I can't imagine I'm going to actually get a lot of time to experiment. If I win the lottery, although I would have to start doing the lottery, I might get somewhere. Have I missed any? Yeah, missed one there. I need to upgrade my editor. This is an old version of Sublime Text, and I haven't got round to upgrading for a while. Okay, let's build that. Need a system for next week's lottery numbers. Yep. If you won the Euromillions, would you spend any on RISC OS? I would spend it on myself, making sure, and other people, to make sure that I've actually got enough time to be able to do things. Would I give it to anybody else? They'd need to provide some actual evidence that they're interested in doing things. I would not spend it on things like RISC OS Open, because they offer no real plan for the future, and without doing that, it's not going anywhere. Sorry, not only do they offer no plan, they have not wanted to actually do any work. Dave says he would employ rule, but not as engineers. That actually might not be unreasonable. The thing is that as technical people, they're not wanting to be involved in that. Right, I am not getting involved in that discussion here. I could go on a big long rant, couldn't I? And yeah, I think we have some very similar views, Dave and I, on some of this. Did I not just compile? Oh, I didn't include student. It's nerd sniping. I have yet to go and reply to the so what now thread on the RISC OS Open forums, which I will do. It's just I haven't had the sign constant overflow. All right, that's because it's got a unsigned value in it. It's not a problem. Oh, I missed some here. That's why. Right, okay. Those two need to be R to R. Letters around the right way. Any more? Oh, all these as well. All right, cool. We'll just go through these. I've yet to reply to that particular post because I was giving it time for people to have a bit of a chance to weigh in, and if they did weigh in, then at least we'd know what their views were. But I think it's been like 2.5 weeks now, and it's worthy of you in. Oh, come on. There we go. Oh, I've put one extra. These red comments are called phantoms in Sublime Text, and they're phantoms because they're not really lines. And one of the effects is you press down and it takes you to the next actual line. It skips over these, but I can see them, so I keep skipping 2 lines over them, and then it's not doing the right thing. In the later versions of Sublime Text, they've replaced those with they appear at the side of the line, which means you don't see as much of them, but it does mean that you don't get quite as confused. Oh, right. Undeclared. Oh, another one I've gone. Slight difference between how the Python and C code represents things. Cannot type today, can I? Really bad. Right, how are we doing? Ooh, we built something. That is kind of exciting, actually. I mean, not hugely exciting, but we've at least got something. So the only one we've got is this sign constant overflow, which is actually down to the header file. Yeah, that is my fault. But we should be getting some of these values implemented, just as dummy values. Right, so let's try loading it and see what we can do. os read, no, not os read sysinfo, so kernel intros. Actually, no, we can use, because it should be claiming it. Read sysinfo number 0 to ABC, print ABC. Actually, that's correct, isn't it? Because read sysinfo 0 is read the configured screen size. I think this is the mode 2770. Cool. And then if we look at chips, so this one's got all the way up to register up to 4. So it should be D and E there. D, E. -256. Probably better doing this. A, B, C, D, E. Really weird quirk of BASIC. If you do tilde and then a list of variables space separated, it applies the tilde to all of them. But if you do it as commas, it doesn't. I almost weird BASIC syntax. Never quite get it. I didn't realise it was you that posted that. So RISC OS UK said that that it was him that posted it. No, I didn't realise. And in general, I try to not pay too much attention to who is saying something. Right. I say I will get back to replying to it. It's just I have been giving it time for things to settle, so that there is also justification for what I'm trying to say. I obviously said a lot in my presentation a couple of weeks back, so I didn't think I needed to immediately. Okay. Right. Am I feeling okay about this? Am I? Yeah, I think that's all right. I think we've got a basic implementation, as in simple implementation. So what we're going to do is we're going to go and add that code and commit it. Simple implementation of os read sysinfo returning dummy values. Return dummy values with the errors where we cannot support them. Right, so having done that, let's see if we can go and put some tests in for it. Yike. Recompare. Test code. There we go. Fine, do that. So if you have a look in here. Oh, actually, the best thing for me to do is to have a look at the introspection file, isn't it? So we have a look at the test file here. So all the read sysinfos we can now make active. So not CPU ones, not control register. Startup should print os memory and read sysinfo 9. Well, that's not going to do anything useful, but it will call it. Yeah, let's not do it. Let's do the 6 error on unknown. That's a paramedic only, and that's paramedic only as well. We want to get this unique ID, the platform, check whether invalid works, and then we're done with those calls. I don't have very many read sysinfo calls. Maybe I should have some more of them. I should probably write some more tests for those and make sure that they're actually being exercised. But we've now got some of those. That's anything that's got prefixed with bin read sysinfo, which makes sense, I suppose. Read sysinfo. Oh, look, here we go. Got a bunch of them there. Go over there. Did we actually do mode test? I don't see a mode in there. What's mode? Ooh, I don't see the mode being tested. Have we actually got a bit of code that we've never actually used as part of our tests? It's possible. It's possible I've written this code and it's never actually been exercised. Let's have a see, shall we? Pyromaniac. Read sysinfo_mode in test code. It's tested as part of the VDU system. Okay, well we can maybe just copy that one little bit over, because it should be part of the introspection. I think it should be part of it. It makes sense that it be part of the introspection. Help read this info mode. There we go. That calls an autumn one. That sounds like a good thing for me to copy over. How do I copy it over? I just want to edit the file, be easier on it. Read this info. There we go, 01. And I should then synchronize them later, but we'll just try going that. And that needs to be enabled as well. I'm leaving the startup out for now. Right, okay. So make tests. No, don't make the test for Pyromaniac. Make tests here. You have to go through all of the OSBite tests first. I have some ideas for making the build service a bit faster. Oh, I forgot to copy the source over, didn't I? And build it. Well, that was a bit dumb. Let's go and find the source. So I copied the source over, I didn't actually build it, that was the problem. So make. Yeah, now we should be able to run the tests. I should have copied the expectations over as well, shouldn't I? Everything's returning not implemented, which is what we expect, because we told it to return not implemented. Oh, that's interesting. It's coming back without... Hang on. Why is it giving me answers for that? Surely I shouldn't be getting a result back from readsysinfo. That's kind of odd. Unless I thought I set it to be 0 anyway. Right, expectations. Expectations for introspection. All of the readsysinfo ones, except those two. So yeah, because those two are due to reconfiguration. And that's error number, yeah. I'm a little confused as to why this readsysinfo unique ID is actually giving me a value. Did I not? Readsysinfo unique ID. What number is it? It's number 5. So is that Ethernet address? A little bit confused by this because I'm not actually sure which ones are which now. Discuss kitten. Which one's 5? 5 is raw unique ID. So raw unique ID. Ethernet address. Raw unique ID. 0, 0. Oh, 3 and 4. Hang on, was that me? Oh, because I copied it from above, didn't I? That's why. Yeah, so that's what came out wrong there. Let's run the tests again, and we'll see the differences. We're nearly at time for the day, so I'm going to get this to the point where I've actually got something out for the RISC info, and then I'll update the configuration. Sorry, the status in RISC OS 64 status repository. It's possible that we should have a separate implementation for it's implemented but it's not right. Oh. That's quite pretty, isn't it? CD dot didn't build the code. Actually, platform class, we should be able to return something for, shouldn't we? Yeah, we should probably be able to return something sensible for platform class. Bounce that over to the left again. See what we can do here, shall we? So null uint32t platform flanks. Oh, I know what I'm going to do. I'm going to copy all this and I'm going to make them all return true. So I'm just going to have bing, 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 bing. If 1, oops, no, don't press return, delete. Platform flags all equals that. There we go. Oh, I missed one. Power off support. No, for some reason that's separate. Oh, because it's not in the same class in the original. Platform forwards valid is all of them, and then R to R to R. There we go. Right. Build that, please. Nope, didn't work. Error is not used. Yeah, it is. It's right there. I missed some semicolons. Oh, that's interesting. Those values are not present in the header. I've got a colon in there. So yeah, we need to define those. One shifted left something and one shifted left something. I don't know what the something is, but we'll find out. Where's platform class? Here we go. I thought it was in there. Hang on, what? Of course, that's confusion. Python constants file. It'll be at the bottom here. Here we are. These ones here. One shifted left 5, one shifted left 6. They should go into the header file eventually, but I haven't put them in there apparently. Build. Oh, I've missed my semicolons off all of these lines. And that line there. And that line there. Platform flags valid and platform class. Yeah, getting tired now. Flags valid. Class. Equals. There. Just some discussion about getting graphics in different formats. Pretty sure that Private Eye does artworks. It's pretty good. And artworks. It's in the text. There you go. Sprites, GIFs, JPEGs, draw files, and artworks. So there you go. Right, that's now doing its thing. What's this complaining about? It says uninitialized uninitialized variable. Very good point. Let us initialize it to 0. Now let's give our tests a whirl. Sorry. Make tests. So I have this idea that maybe if I started up a Docker instance that is just sitting there waiting on the build service, and then we go and send it messages to say how you want it configured, that would actually speed things up a lot. I mean, really, I'd like them all to be lambdas, but I just haven't got around to doing that kind of thing. It's a lot more complicated. Right. All of these look correct. Everything is not implemented. That is what I want to be able to see. For this one, 0 value. Still getting out a high word of something's wrong there, surely. Have I misimplemented RISC-Info 5 rather? It's quite probable I have. And this one, it's saying everything's set. Yeah, we'll fix that up later, but for now we can just return set for everything. And that one will return bad RISC-Info. Oh, we could potentially return the correct answer for that. That would be quite a nice idea. Okay, so rename those. Let's go and have a look at this. So we just do that and this. I want to change, which one was it? Oh, I've forgotten already. What was I looking for? Yeah, I wasn't sure what's going wrong with RISC-Info 5. That unique ID. Still implemented it wrong. I'm really quite awful, aren't I? Yeah, there was something I just saw though that I was thinking, oh, I should do that. Bad reads this info. 1EC. EC. We can probably return that. I'll just mark it for now. Fix me should be bad read sys info. Okay. It's all pretty dull. I'll make tests again. I'm sitting in the dark again. What? I wonder if my lamps moved a bit. Not come out too badly. When I started this, it was so bright outside, it was shining and you could barely see me. That's what happens in winter, isn't it? Okay, come on. All looking good here. Yes, we've got test all passing. So bin, expect, and s. Add, oops, kernel introspection. No, rm kernel git ignore start on my FFA. Shouldn't be checking in the module. Right. Added tests for the OSRead sys info calls. Tests are now present and mostly just check we haven't progressed. No special behavior. Okay, push that. Right, make. Right, that's built. And oh, I've rebuilt it. Does that mean that my tests weren't right? I think I may have changed some things, so I need to just go and tweak it. Oh, that's frustrating. Did we ever get around to making Private Eye build entirely in CI? I think we nearly did build it. Yeah, Dave's got all his fancy bits in here that do these things. Yeah, I think I tried doing it a number of different ways and then couldn't really make it work, but Dave managed to sort it out in the end. Yeah, I think I'm pretty sure it just needs, because we don't have a... Oh, we do have releases. We did get around to doing that. Oh, how cool is that? All nicely built and set up and stuff. Whew. Yeah, I did make a tweak to it. Commit minus a minus amend. Rename. There we go. Push minus F. Right, we have a look at it now. This one here. We should see that one of them just failed because it was wrong, and this one should now be passing. And what I'm going to want... No, it didn't pass. What went wrong? Oh dear, lots of breakage. Oh! Build ordering's wrong. Let's just go into here. os read sys info needs h.modhead as well. Commit, amend on that. Yeah, it's fine. So what happens if you don't clean it and then rebuild? There we go, it's building now. Yeah, successful, cool. So yeah, what I was going to do was go back into status, catch up with where we are. Ooh, still got things in here. Ah, the modules-wise stuff I was doing last night. OS-wise rather. Update the OS-wise documentation to reflect. Don't push that yet. So we want to make that and make a 64-bit as well. Don't know that it'll work in 64-bit. Row build 64. Sorry, I can't even remember how to do this. This is not very sensible. Build 64. Wow, my memory is just sucking these days. And whilst it will run, it won't quite do the right thing because bytv can't actually handle the claims of calls yet. But it's good. It's going to be good enough. Okay, so let's have a look at this. Kernel intro. Markdown, please. There we are. Right, so we've done that one. We've done that one. These are done, but they're not actually correct. I'm not sure what to do about that because it's like it's got fake values, but it's not actually. I don't know what to do. I'll mark them as in progress, and then I'll work out the best way of doing those. So there we go, all in progress. Oh, actually, those last few have not been out of date because I haven't actually implemented them at all. Right. And we know that 64-bit doesn't work because you can't claim claim vectors yet. So read sysinfo. The SWI call is implemented. The rest of it isn't. And both those byteVs are now implemented. Anything else it says down here? Nope, that's all it done. And then I want to update the status stop markdown page. So this is something that I try to do as much as possible. Stub. Is it a stub? It's not quite there yet. I'm not going to mark it as done yet because we're not actually at the point where I feel comfortable with it. But we've got some parts of it done. What I was trying to say was that I try to make sure that I update the status all the time so that there's a representation of where we're up to on the wiki pages, and anybody who goes to look at it can see exactly where we are right now. And it's usually about right. New kernel introspection module and status update. The 64-bit vectors yet. That's good. And we'll push that. So that is everything that I was planning to do today. I think I wanted to get a little bit further, but I didn't. Let's just way things go. We have a look at the actual status. So I've just pushed that change, and it will go off and build various parts of it. And if we have a look now, hopefully reload the page. There we go. Wow, 8% complete. I could actually have said that it's we're in investigate. I could say we're in investigate, couldn't I? Yeah, I'm going to put it as investigate. Why not? Because we are. There we go. Just update that one, might as well. At least give me a little bit of a feel that I'm getting somewhere. But we've got an 8.3% total completion here, which isn't too bad. It's not a huge thing, but we're getting somewhere. We're going to be able to get to the point where things are stubbed. I'll probably change these declarations so they actually have a differentiation between returning the correct values and returning a value, because then we can actually start ticking things off and maybe extending things as we need to in the future. Yeah, so next week we'll have a look at doing some more in OS read sysinfo if we can, and trying to abstract it a little bit more, and then OS platform features. I think finally we'll go to OS memory. Read mem map entries and info we might get done, but I think both of these are going to be just like static values that are not going to be particularly interesting. So they're very much like the read sysinfos, I suppose. Yeah, so that's where we're going to go to. I hope you've enjoyed things. I hope it was, as Chris said, intriguing. There's not a lot of very interesting things in this because largely we're just going, yeah, that seems like a good answer. But there we go. Yeah, next week, again, 1 o'clock UK time. That'll be the 21st. So that's the last one before Christmas. It might be just a short session, depending on how I'm feeling, because I'm not sure that I want to be doing many hours. We'll see anyway. And then we might have one on the 28th, or we might not. I'm not quite sure about that. Talia suggested that it probably won't have a large number of viewers. Not that we've got a lot, but yeah, we'll see. I'll post up some comments on the RISC OS Open forums on this thread to say what we've done today, and hopefully that'll keep people up to date. See you all next week. Hope you have a good weekend. Enjoy.